Hello, fellow Econauts, and welcome back to our show. I'm here with my brother Ben the Rocketman. Hey, Ben, how are you?
I'm fine, thanks, Simon. How's it going? Hey, fellow Econauts. What's the topic today, Simon?
Topic today is warp drive.
Hit the intro.
What is a warp drive?
Warp drive, I think it's a term a lot of sci-fi nerds know. It is pretty much describing a way to bend space-time around a spacecraft to enable to fly faster than the speed of light. That's in a nutshell what it does. It comes from Star Trek.
Why is a warp drive desirable?
We have talked about space travel in a couple of episodes now and about different types of propulsion. And one big issue we are facing is that space is big, very big. So everything is very far away. And unfortunately, we have a space speed police that's called the speed of light, and we cannot travel faster than the speed of light. So that means the faster away we are, we get sort of into a limitation how far we can travel, even if we were able to travel with the speed of light. So the closest star system, I think, is Alpha Centauri with was it 1.8 or was it 3 point something years? Anyway, multiple years, just to be on the safe side, because I need to look up the number, but multiple years away, even with the speed of light. That means even if we were able to travel with something that is as fast as light, it would still take us a year or two or three. And that's the closest one. Others are hundreds of light years far from us. So, in other words, if we can't find a way to travel faster than the speed of light in whatever way without violating the theory of relativity, we cannot travel to other star systems. That's the problem. If we don't consider generation ships, but then that's a complete different can of worms we're opening here.
When will we see the first warp drive?
Well, that's a good question. I think the how long is a piece of string is the answer I want to give here. To expand that answer a little bit, first of all, the warp drive stems from Star Trek, so you could say we have seen it already on TV many times. But joke aside, Star Trek has actually inspired a whole generation and often sci-fi has inspired actual scientists to investigate something in a certain direction. And same with the warp drive. In 1994, Miguel Alcubierre investigated mathematically the possibility of warp drive, and he came up with a solution that would not violate the relativity according to Einstein, and also would make traveling faster than the speed of light possible. However, the caveat with his finding was that you would need a very special kind of matter which has not been discovered yet in order to make this possible. Since then, there has been a lot of other research been done. The current status is, as far as I know, that with normal matter, it might be possible to build a warp drive, but you would only travel with speed lower than the speed of light. So, long story short, we don't know. We are very early. If it's possible at all, we don't know yet. It seems to be possible from the theoretical side of things, from the mathematics, from the physics. It seems to work out. However, having something theoretical and you can calculate it doesn't mean you can build it tomorrow. So I think it will take a while, maybe a couple of generations even, before we are able to build a warp drive, if it's possible in the first place. And even if it's then possible, we have to figure out if we can then travel faster than the speed of light with it.
One experiment that everybody can do, even on Earth, if we want to experiencing how it works with Mars, for example. If we see, a disk flying through space and we would throw the ball directly at the disk, we would probably not hit it. So we have to kind of anticipate where it is. That's kind of I know very
Kind of, yes.
simplistic. There are more moving parts in space, obviously, but I think it does illustrate very well what needs to be done to actually hit, the target, right? And now the target is even further away. And if we go even further, it, what I'm trying to say is if we miscalculate just by a teeny tiny bit, we miss the target, right?
Absolutely. That's absolutely correct. Even one miss shot of your propulsion system, like a second, is enough to miss by 100 kilometer. So, it doesn't sound much, and maybe you still come by, but missing something by 100 kilometer in reality is a lot. So, yes, absolutely.
And if we now put that in perspective of missing not just 100 kilometer, because the 100 kilometer will, you know, exponentially go fast, bigger and bigger and
Yeah.
bigger if we go to another system, which means there
Yes,
is
yeah.
still a lot of research needed to be done to actually find a way to go to
There's
another system.
there are actually theories that after a certain amount of time we cannot predict anymore what happens. So I think the timeline is like, I don't know, there's X amount of years, like a large number of years, and that in the thousands probably, where you cannot make a prediction anymore what happens because there's too many variables at play which you cannot, you cannot say what happens. You cannot predict the influence. I mean, just take on Earth, for example, who would have predicted certain events that have happened? And you cannot plan even one life. One lifetime is not is already too long to completely design in a way. And now imagine you send something somewhere, you don't know what happens along the way. So there's so many things you cannot predict. Voyager 1 and 2, our two spacecraft that have left the solar system after 70 years. There's also lots of things along the way that happened. Still, they're working, um, and they could recover one of them just quite recently and make it usable again in a way, not fully. Um, but yeah, my point is there's too many variables, especially if we have long periods of time to consider. That's why it's desirable to come back to the question from earlier. That's why it's desirable to have one way to shorten the amount of time it takes to travel from A to B. If you think of it really, all inventions humanity has done are time machines. The fridge is a time machine. It prolongs the amount of time we can keep food. The car is a time machine because with the car we can travel also from A to B in a short amount of time. We can do something else with the time. We're opening up time for something else. And the same would be with a warp drive or any other device we are developing to enabling interstellar travel.
To end this show a little bit on a positive note, I think humanity has always found a solution for a problem, right? Um, if we would be able to go back in time and would tell our ancestors, one day you will be able to fly, they would probably think like we are nuts, right? But here we go. We actually have the ability to fly from one location to another. And the same is if we would like tell someone, Caesar would tell, hey, one day we would be able to go and walk on the moon. He would probably say, like, that's insane. But here we go. We actually have the technology. So we don't really know what might happen in the future, right? There's a possibility that maybe it's not called the warp drive, it's maybe called the cold fusion drive, whatever it is, that actually allows us to find a way to go to another system.
Yes, I cannot add anything to that. Very nice.
All right. Well, then, let's end it for today. I hope you had a very good episode today. We had a lot of fun, as always. If you like this episode, please don't forget to leave a like and subscribe if you haven't already.
And don't forget to hit the notification bell. Also, we've already done quite a few episodes at this stage, and we would like to invite you to watch them as well. You can find them here and here and here and here and everywhere.
Everywhere. All right. I hope you have a good day. I see you next time. Bye bye.
Bye.